Okay, so for this first problem, we're going to use the limit definition of the derivative to find the derivative of 1 over x. So that is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. And so we're going to use this for our function, and that's going to give us the limit as h approaches 0. F of x plus h will be 1 over x plus h when we put x plus h into our function, minus 1 over x over h. Since we have a small fraction instead of a larger fraction, we're going to multiply top and bottom by the common denominator of the small fractions, which is x times x plus h over itself. So we're just really multiplying by 1. And when we distribute, we'll get the following. So when we distribute in the numerator, the x plus h's will cancel with the first term. We'll just be left with an x. And the second term, the x's will cancel, and we'll be left with an x plus h. And I'm going to keep that in parentheses. And in the denominator, we'll just multiply across. So we have hx times x plus h. So we'll simplify the numerator, because if not, if we put 0 in for h now, we'll get a 0 over 0. And that's an indeterminate form. So this gives us x minus h over h times x plus h. And we can see here in the numerator that the x's will cancel out. And so this will give us the limit as h approaches 0, negative h over hx times x plus h. This simplifies further because we can cancel one h from the numerator and the denominator. And we're left with the limit as h approaches 0 of negative 1 over x times x plus h. Now we can let h go to 0. It becomes very, very, very tiny, so that's like plugging in 0 in place of h, and we're left with negative 1 over x times x plus 0, or x squared. And so the derivative of our function is negative 1 over x squared. Part B of this problem asks us to evaluate this derivative when x is equal to 2, or to find f prime of 2. So we'll put 2 into our derivative function. That gives us negative 1 over 2 squared, or negative 1/4. And so that's the slope of this function when x is 2. And finally, okay, so now to find the equation of the tangent line, we're going to use our equation of a line, which is y minus y1 equals the slope times x minus x1, where x1, y1 is a point on the curve. Since we want this specifically when x is 2, to get y1, we can find the function value at 2 and put it back into the original function, and that'll give us a 1/2. And then we know that the slope when x is 2 is negative 1/4. So we have everything we need to write the equation of the tangent line. And that'll give us y minus 1/2, the y value of the point, equals the slope times x minus 2. And it's fine if you want to leave the equation of the tangent line in this form, or you could also multiply out, but this would be perfectly fine.